Good day everyone. In this video, I will be discussing about equation of a plane. First, let's define what is plane. Plane. Unlike a line, a vector that is parallel to a plane is not enough information to determine that plane. So if I give you a point and I give you a vector parallel to a plane, this is not enough information to write the equation of all the 8 unique planes. There are multiple planes that will be parallel to that vector and through that plane. So instead, you need a vector that is perpendicular to that plane. That is the biggest difference you get to know. A line has to be parallel, a plane has to be perpendicular. Equation of a plane. N or normal vector times r minus r naught is equal to 0. Let's say is the vector ABC. Remember that r represents any point in the plane or a vector that goes to that point at least. So r is xyz. So this will be x minus x naught, y minus y naught, z minus z naught equals 0. So if we multiply this out, it will lead us to a multiplied by x subtract x naught plus b times y minus y naught plus c times z minus z naught equals 0. So this is called the scalar equation of the plane. And then, there is one or other equation when all of this is multiplied out and you combine the like terms. To use this idea for an example. Example number 1. We are going to find an equation of the plane passing through the point 3, negative 1, 7 and perpendicular to vector n, which is 4, 2, negative 5. So like before, this is not gonna be a unique equation. That's gonna be one equation that's based on this point in this vector. We could choose a different point, we could choose a different vector. So what we're gonna do is we're gonna take our normal vector n, which is that 4, 2, negative 5. It's going to be dotted with r minus r naught. So r gonna be x, y, z. Shall be x, y, z minus our point. So x minus 3, comma, y plus 1, comma, z minus 7 equals 0. So this is the vector equation of a plane. You can leave it like that. Other way, you might express this as 4 times x minus 3 plus 2 times y plus 1 minus 5 times z minus 7 equals 0. This is the scalar equation of our plane. Like I said, the last way that people do it is they multiply out the 4 to negative 5. If you did that, you would get 4x plus 2y minus 5z plus 25 is equal to 0. This form is called the linear equation of line. Now, if you are asked to graph a plane, the linear equation is most helpful. So if I give you this equation, how would you go about graphing the equation of a plane? You're gonna find the 3 different intercepts. So plug in x and y or 0, find the z-intercept. Plug in x and z or 0 to find y-intercept or etc. Next is example number 2. We are gonna find an equation of the plane that passes through the following 3 points. P is 1, 3, 2, Q is 3, negative 1, 6, and R is 5, 2, 0. Now, we are going to find a normal vector n. We have a plane with these 3 points. How can I use these points to find a vector that is perpendicular to the plane? So, we're gonna find 2 vectors. Find PQ and PR, then I take their cross product. I'll end up with a vector that's perpendicular to both. PQ, if I do 3 minus 1, I get 2. Negative 1 minus 3 is negative 4. And 6 minus 2 is 4. And then PR, 5 minus 1 is 4. 2 minus 3 is negative 1. 0 minus 2 is negative 2. To cross them, I use determinant ij key. I is 8 plus 4 is equal to 12. J is negative 4 subtract 16 is negative 20. But you have to flip side is positive 20. Negative 2 add 16 will give us 14. You can definitely use, and if you want to, any scalar, multiply is still gonna be perpendicular to the plane. So I normally simplify it. I can show divide it by 2 and get 6, 10, 7. So our equation is going to be 6. So our equation is 6 times x minus 1 plus 10 times y minus 3 plus 7 times z minus 2 equals 0. This form is okay. If you choose to multiply everything out, you get 6x plus 10y plus 7z is equal to 50. I hope that my discussion is clear to you and all of us learned something new. Thank you very much for listening.